Everyone. Now we are going to see an interesting topic. It is a case study based class. The topic is copper versus silicon. Copper is a good conducting material and silicon is a semiconducting material. So what about their performance? What about their temperature based performance? So that and all we are going to see. First, we should know about the copper. Copper is a good conductor of electricity and silicon is a semiconducting material. Copper is mainly used for electrical wiring and power transmission, but silicon is mainly used in a electronic and semiconducting devices. The difference arises from there the electronic structure, energy bands, conductivity, and temperature dependence. So next is executive overview. So two material solve different problems. How two materials? So material choice first thing. The copper first thing is we consider it copper. Why does copper conduct electricity well? What is the reason for that? So copper is a large number of it contains a large number of free electrons and its valence and conduction band are effectively overlapped. So that means there is no gap between a conduction band and a valence band. It is very tightly overlapped. The electrons can easily move when electric field is applied. Then silicon, the strength of silicon next we consider. So silicon is conducting material. We know silicon has four valence electrons, and each silicon atom form four covalent bonds with the neighboring atoms. So at low temperature, very few electrons are available for conduction, and when energy is supplied, some electrons move from valence band to conduction band. This produces electrons and holes which contribute to electrical conductions. And the energy gap of silicon is it is approximately energy gap is 1.12 electron volts only. What about their band structure of comparison? So band structure when we compare the material copper it is a conducting material and the band gap is approximately 0 for copper and their conductivity is very high and the resistance of a copper material is very low and it is mainly used in cables. Then if we are going to see about the temperature dependence, how copper and silicon temperature dependence. When temperature increases, lattice vibration increases. What is lattice? Lattice array of atoms. So electrons experience more collisions when the lattice vibration is increases. The electrons which are seated in the lattice also get vibrated and the electrons experience more collision. So electrical resistance increases automatically and their conductivity decreases. When for temperature increases in silicon, more electrons gain sufficient energy to cross the band gap. So the number of charge carriers increases and the electrical conductivity generally also increases. So resistivity automatically here it is decreases. So why copper is used for wires? Copper is a preferred for electrical wiring because it has a high electrical conductivity, low resistivity, good ductile material copper is, and good thermal conductivity, and it is a good mechanical reliability material. So relatively easy fabrication into wires. General applications for uh, copper is a house wiring, then power cables, transformers, motors, generators, and electrical conductors. Then why we use silicon for electronics? So silicon is especially useful because it is conductivity can be controlled. So copper is a very good conductor, but when compared to silicon, we can control its conductivity. Its electrical property can be modified by doping because it's a semiconducting material. So N type and P type two silicon materials are there. So we can control the conductivity. So when what is the N type? Adding a donor impurities such as a phosphorus or provide additional electrons. P type semiconductor. What is P type? Adding acceptor impurities such as boron. Boron when we dope, it creates a holes. So where this controllability allows silicon to be used in electronic devices, that electronic circuits, diodes, transistors, ICs, that is integrated circuits, solar cells, sensors, and microprocessor. So finally, see, so its case study of electric vehicles. They are used. These are all their applications where they are using electric vehicles are fully based on this. A practical system use both material, each where it is strongest. So both material are combinedly used in electrical vehicles: battery, copper bus bars, inverter, then silicon motors, sensors, control units it is used. Then criterion, copper and silicon. So final conclusion for this resource profile. So major recycling routes, mining, mining of print, but silicon energy intensive fabrication, high process complexity. Then risk is price variability and supply concentration, yield, scaling, and equipment dependence. Which one is silicon material is. And design response, use efficiently, recycle and recover, but it improves process efficiency, extend device life. Silicon material. Decision framework. What must it do? So carry current to control current. So what is the geometry? Wire, contact wires, wafers, or devices. So what is a scale? Prototype, mass production, or a high volume. What is the life cycle? Cost, energy, repair, and recovery. So finally, what we conclude, what is the real life applications where it is used, that and all we have a small idea about that. So finally, when we come to now we come to the conclusion. Copper is chosen when we need electricity to flow easily, whereas silicon is chosen when we need electricity to be controlled. This is the fundamental reason why copper dominates electrical wiring while silicon dominates modern electronics. So copper, general summary is copper material, it have a high conductivity, easy electron movement, electrical wiring and power transmission. But silicon, controlled conductivity, electrons plus holes. Semiconducting device, it is used in semiconductor device and electronics. Thank you.